My name is Mark Cardamis and I'm here at the University of New South Wales. I'm a researcher working in smart farming, and welcome to our Grow Pod. So my area of research is on non-contact sensing for protected cropping. So one of the things that we do here at the university is we look at building and testing new novel sensors. We build and test them in prototypes like this, but there are times where we need to go and test them out in real commercial environments, and that was where we worked with Vertical Patch, and we came across them through the Future Food Systems CRC, and they basically collaborated with us so we could test in a real commercially available indoor farm.
Hi, I'm Pascal Nakhle. I'm one of the co-founders of Vertical Patch, and we are an indoor farmer. We got introduced to UNSW through the Future Food CRC program, and we've developed a relationship with them for over now 2.5 years. And we've got a project going on with the Internet of Things, which is taking all the sensors and controls in a controlled environment or a container grow pod like this, and providing information to us on a user-friendly dashboard where our farmers can interpret the information and act on it.
A lot of our new research is in indoor farming. So one of the advantages of indoor farming is obviously you can control the environment, so you can get crops all year round. One of the downsides is that it does use a lot of electricity. So a lot of the research that we're looking at now is how can we maintain crop yield while minimizing that energy use. So we really look at doing dynamic scheduling of lighting so that we can sit there and really optimize the photosynthesis and don't let any extra energy go to waste. So there's a couple of different things that we are testing here in the Grow Pod. So one of the things that we're looking at now is energy optimization. So we look at monitoring the environment and then adjusting the lighting intensity and the spectrum so that we can minimize energy while maintaining yield. So here we have some experiments, and we've shown, I think, up to 40% decrease in energy over a 2-week experiment, and we've had, comparable yield.
My name is Wen Hu. I am a professor in School of Computer Science and Engineering, UNSW. My expert area is Internet of Things, where we connect everything to optimize the environment. In this project, we try to use Internet of Things technology to optimize the control of the greenhouse so as to optimize the yield of the crops and minimize the energy consumption of the greenhouse. So the Internet of Things we deploy in this greenhouse is based on energy harvesting, solar panel. So therefore it doesn't need battery. So therefore it means like harvest energy from the lights that generate by the LED that used for photosynthesis. We use that as a side channel to power our devices. So therefore we don't need to maintain the devices as well as do not produce any e-waste.
So the crops that I've got behind me are basil, where we look at the leaf water content, and then strawberries, where we actually do sweetness detection on the strawberries. So we have a new novel sensor for that, where we can actually detect it from about 1/2 meter away.
The sensor that we connect include temperature, humidity, light intensity, etc. So those are very important for us to estimate the photosynthesis rates of the crops. The control side of things, we control the HVAC, the temperature, the light intensity, and the spectrum so as to optimize the photosynthesis rate depending on their stage. We build a model, a machine learning model that tells you the relationship, how to estimate the photosynthesis rate based on those measurements that we have. Based on that, together with the energy price, the large language model try to reason that, minimize the energy cost, and maximize the yield.
So that's some new exciting tech and sensors that we've got. For this project, we're in the beginning stage. We only started a couple of months ago. So we basically set up our new test environment, and we're basically getting the space ready so that we can do our research over the next couple of years, and then really use this as a base for us to then go out and get this commercially out to the market.
So we're hoping to achieve out of this Grow Pod and this project, all information that's being captured here is reported to us on a timely manner, and our farmers can act on it as quickly as possible. What this allows us to do is roll out these Grow Pods to anywhere in Australia, overseas, and Vertical Patch can still be a farm manager to them, and hopefully we can provide quick action items if anything goes wrong. We've got 2 container model types, a 20-foot container farm management system and a 40-foot. So each one is a combination of 2 container farms joined together to form practically 3, about 100 square meters of grow space, and that allows us to be economically viable. because a normal container farm is not viable on its own. So you got to work out how to get the unit economics working. But the farms will be either fully strawberry, fully mushrooms, fully leafy greens, so product specific. We've got container farms that are also for the mushrooms, so that will be available also in probably a couple of months' time. With the mushrooms, it's purely, in terms of reporting, there's a lot of sensors with carbon dioxide in there, the growth of the mushroom, any disease control, all captured through this project actually. And the good thing with container farms, they're scalable and modular, and you can put them anywhere and put them on top of each other, etc., in small space. All our produce is locally grown. We are part of the carbon solution, low carbon miles, sustainable, etc. All our customers want that, and we provide our customers with what they want us to grow. Our vision right now is we've built up all these farms around Sydney. We want to move overseas, still be part of the farming solution over there, and we're going to do that through container farming. There's many container farming solutions out there. What allows us to do with this container farm is we're working with UNSW to provide the actual farm management system to run that farm, and because then it's all run via vertical patch and UNSW farm management system. So having that solution provided to our customers is very valuable.